Physics Part 192. The photoelectric effect. At the end of the first section of chapter 9, you should be able to show an appreciation of the particulate nature of electromagnetic radiation. You should be able to show an understanding that photoelectric effect provides evidence for a particular nature of electromagnetic radiation, while phenomena such as interference and diffraction provide evidence for a wave nature. You should be able to recall and use E is equal to HF. You should be able to recall the significance of threshold frequency. You should be able to explain photoelectric phenomena in terms of photon energy and work function energy. You should be able to explain why the maximum kinetic energy of photoelectron is independent of intensity, whereas the photoelectric current is proportional to intensity. You should be able to recall, use, and explain the significance of HF is equal to pi theta plus 1/2 mv max square. Some of the electrons in a metal are free to move around in it. It is these free electrons that form the electric current when a potential difference is applied across the ends of the metal wire. However, to remove free electrons from a metal requires energy because they are held in the metal by the electrostatic attraction of the positively charged nuclei. If an electron is to escape from the surface of a metal, work must be done on it. The electron must be given energy. When this energy in the form of light energy, the phenomenon is called photoelectric emission. Photoelectric emission is the release of electrons from the surface of a metal when electromagnetic radiation is incident on its surface. Demonstration of photoelectric emission. A clean zinc plate is placed on the cap of a gold leaf electroscope. The electroscope is then charged negatively and the gold leaf deflects, proving that the zinc plate is charged. This is illustrated in the figure. If visible light of any color is shown onto the plate, the leaf does not move. Even when the intensity, the brightness of the light is increased, the leaf remains in its deflected position. However, when ultraviolet radiation is shown on the plate, the leaf falls immediately, showing that it is losing negative charge. This means that the electrons are being emitted from the zinc plate. These electrons are called photoelectrons. If the intensity of the ultraviolet radiation is increased, the leaf falls more quickly, showing the rate of emission of electron has increased. Demonstration of photoelectric emission. The difference between ultraviolet radiation and visible light is that ultraviolet radiation has a shorter wavelength and a higher frequency than visible light. Further investigation with operators like this leads to the following conclusion. If the photoemission takes place, it does so instantaneously. There is no delay between the illumination and emission. Photoemission takes place only if the frequency of the incident radiation is above a certain minimum value called threshold frequency F0. Different metals have different threshold frequencies. Whether or not emission takes place depends only on whether the frequency of the radiation used is above the threshold.